Hello my dear friends and students. Welcome to the today's session where we have to see the different types of DC generators. A small overview on the last session where we have seen the basic construction and working principle of a DC generator. After that we have seen the EMF equation for the DC generator, which is nothing but E is equal to P phi NZ upon 60A. Now after that, in this session we have to see the different types of DC generators. So next so DC generators broadly classified into two types: separately excited DC generator and self-excited DC generator. We'll discuss some basics. So the field winding is also called as exciting winding, and the current carried by the field winding is also called as exciting current. Thus, supplying current to the field winding is called excitation, and the way of supplying the exciting current is called method of excitation. Depending upon this method of excitation used, the DC generators are broadly classified into two, that is nothing but separately excited DC generator and self-excited DC generator. In short, in separately excited DC generator, we use a separate DC supply to excite the field winding. But self-excited DC generator, in this type, whatever EMF is generated at the output side, some part of that EMF is taken as an input to the field winding, then it is called self-excited DC generator. So these self-excited DC generators are further classified into three: shunt, series and compound. These are nothing but the depends upon the position of field winding and armature winding. These three are further classified. So in short we can say, if field winding and armature winding are in series, then it is called series self-excited DC generator. Similarly, if field winding and armature winding of a DC generator is in parallel, you can call it is a shunt self-excited DC generator. And when field winding and armature winding are partially series and partially parallel, then it is a compound self-excited DC generator. So next we will see one by one. So this is separately excited DC generator. As I have mentioned earlier, you can use separate DC supply for field winding. So you can see in this circuit diagram, DC supply separately we are using for the field winding. So IF is nothing but the field current, IA is nothing but the armature current, IL is nothing but the load current. So in separately excited DC generator, when the field winding is supplied from the external separate DC supply, that is excitation of field winding is separate, then generator is called separately excited generator or DC generator. The field winding of this type of generator has large number of turns and thin wire. So length of such winding is more with less cross section area. So resistance of this field winding is high in order to limit the field current. Next, if IF is the field winding, IA is an armature winding, IL is an load current, then we can write the final voltage equation for separately excited DC generator as V is equal to EG minus IA RA minus V brush. Okay, the same equation we can write in the form of EB also, where you can rearrange this equation. EB is equal to V plus IA RA plus V brush. Here I would like to mention what is meant by V. V is nothing but the terminal voltage or the load voltage or voltage across the load. EG is nothing but the generated voltage by that generator. IA into RA is nothing but this is also called as an armature loss, where P is equal to I square R or V is equal to IR. It is some type of voltage drop over here. So in short we can say that generator has to generate that much amount of voltage which should overcome the this armature losses plus brush losses and plus terminal voltage. It can be provide the terminal voltage also. So the voltage equation in the form of load voltage I written over here, and if you want to write the same equation in the form of EB you can write, or EG you can write. EG is equal to, or generated voltage is equal to, V plus IA RA plus V brush. So this is all about separately excited DC generator, where we have used a separate DC supply to provide a exciting current, that is nothing but the IF. Okay, so the next type is self-excited DC generator. As I have mentioned earlier, self-excited DC generator means whatever EMF is generated by that generator, part of that output is taken as an input to the field winding or to the excitation winding, then it called self-excited DC generator. So as you can see in the circuit diagram, generator where armature winding is inside and field winding is parallel. So this is first type of self-excited DC generator, where armature winding and field winding are in parallel. So whatever EMF is induced, that EMF is utilized to provide the load voltage as well as to provide the field current also. So here voltage equation can be changed like V is equal to EG minus IARA minus V brush. Again, where EG is nothing but the generated voltage, V is nothing but the terminal voltage, IA into RA is nothing but the armature loss, and V brush is nothing but the loss across the brushes, which are negligible generally. If they have mentioned the V brush, then only you have to consider, otherwise this is very negligible type of loss. Next, series wound self-excited DC generator. So when the armature winding which is present inside this generator, when the armature winding and field winding comes in series, it is called series excited or series self-excited DC generator, where IA is equal to ISE is nothing but IL. That means same current is flowing through armature winding, field winding and the load. So here equation for the voltage can be somewhat changes, that is nothing but V is equal to EG minus IA inside the bracket RA plus RSE, because whatever resistance of armature and resistance of series winding, these are comes in series. So whatever losses takes place across armature as well as series winding, that we have to consider over here. That's why voltage equation can be changed, remaining all is same. And the last type is nothing but the compound type of DC generator. As I have mentioned earlier, compound type of DC generator means where armature winding and field winding are partially series and partially parallel. So armature winding is present inside this generator. This is partially series winding and this is parallel winding, that is nothing but the shunt winding, or you can say field winding. So here you can say that it is this type of compound generator can be again classified into two, long shunt and short shunt. So long shunt and short shunt, see the short shunt compound generator, only the position of this series winding with the armature is changed. This field winding right now totally parallel with the series winding and armature winding, but in short shunt the field winding is parallel with armature winding only, and after that this series winding comes in picture. Okay, so here also for long shunt we have some resistance in series, some resistance in armature. So again in voltage equation we have to write IA inside the bracket RA plus RSE. RSE is nothing but the series winding. And in next short shunt compound motor also, IA into RA is nothing but the armature losses. With this IL into RSE, yani ki losses across this winding we have to consider separately. Remaining V, EG and VB are the same. So this is all about the different types of DC generators as well as the voltage equation for the same. I think you are getting this one. So the remaining part we will see in next session. Thank you all.